Holy cow, we haven't owned one of these guys in a while. Apologies, I got a little bit of root beer in my room. So, it has been a long, long time since we've had a Nick and Time design update. So I guess it's time to go over what the heck I've been doing in the background for so long. So the Jeep videos have been a little weak lately, and that's because I've been busting my butt figuring out all this stuff. Dude, this takes forever. Oh my god. So, in the current development cycle, we have the Trinity fan controller version 2 for all your fan controlling needs, and the Renix engine monitor 2 Plus for all your scanning needs. And I finally got into a point where I can actually show them off. I kind of went a bit crazy on the design. Just a tad. Maybe. Yeah. So, yeah. I guess we will start with the Renix engine monitor, because that is the more popular of the two. So this right here is going to be running our version 5 software. This here is a version 5 prototype. The last time that I had one of these on the market was January. I've been sold out since January because I've been trying to work on a completely self-reliant design. So this right here is the most complicated design I have ever put together. This is all parts that I put on myself. There's no daughter boards or any extras or anything. This is all mine. And it took forever to get it just right. So the biggest change in the version 5 hardware is definitely our microchip down here. This is a fully embedded design. So gone are the days of using these pre-built boards right here, like the Teensy 3.2 and the Teensy LC. That's how I used to use the designs. It was easy, because I could just plop one of these in there and be good to go. But the problem is soldering all those gosh darn pins. Dude, there's like 80 pins on that. That takes forever to frickin' build. And it's not helpful for long-term stuff. So this is what I've been dreading to make because of how long it was going to take, but it was time. It was finally time to make a professional design. So now we have all the teensy hardware built into my own design. Look at this monster, dude. Oh my god, it's like a freaking computer in here. It's insane. So now we have the microchip built in. I still have to buy the bootloader from PGRC so that we can use the so we can stay teensy compatible. But it's got everything in there, man. It's got the crystals, all the capacitors, the resistors, the reset stuff, power, and just everything. So I guess we should kind of go over why this thing is so much better than the version 4.0. Well, let's go grab a 4.0. So this will be slightly unfair because this is only a version 4. But that's what we were working with. So we had the daughter board in there, and if you'll notice, we had the RTC circuit and a few little things in over here. You know, voltage regulator, some dividers, some data reading circuits, stuff like that. And then you come over here, and you're like, oh my goodness, where to start? Where to even start? Okay. So, yeah, we'll just get into it. So first off, the gigantic battery you'll notice on here is for our clock. So I've now switched to the RTC circuit built into the Teensy. So we have a second crystal that is in charge of keeping time, and the battery saves the time during power off. So hopefully we don't have any more I2C issues. I know with the old the version 4.1 clocks had issues where they would occasionally lose time. So we're not using cheap Chinese RTC circuits anymore. It's hard to beat that entire system for 99 cents, but Reliability, man. Reliability. So now we've got a changeable 2032 battery in there to keep time. That should save time for quite a long time. So that should be cool. So RTC stuff is built in. The USB port, we now have the freedom to put it wherever we want. We're not stuck with trying to fit that teensy design somewhere. So now it's in the side, so we can actually use the darn thing when it's on the dash or whatever. So ain't that cool, eh? Again, messed up on the micro SD slot, not once, but twice. So in the version 4, I had the layout wrong. I had the wrong footprint. So then on the 4.1, I thought I fixed the footprint so the actual slot would fit, and the slot did fit. But somehow I goofed up the pins. They were completely backwards. Apparently the data sheet, the pinout was from the bottom, even though every other schematic on that sheet was from the top. So I had my pins backwards. So yeah, the version 4.1 sockets don't work. The micro SD cards just get really hot, and they don't seem to get damaged, but I would very much recommend not putting an SD card in there because they ain't going to do anything. So as a stopgap, I actually found these really tiny ports that I was able to fit on the footprint just barely. So that makes the thing functional, but trying to get a card in there is damn near impossible, just because of how much farther in it's got to go. So yeah, for version 5.1 or whatever the heck I decided to call the next revision, we're actually going to finally have a proper micro SD slot. It still doesn't do anything. I still have to code the data logging. I've been falling behind on coding because of all the hardware changes. But anyway, we will continue moving over. So over here, we actually have an LCD backlight driver circuit now. So the LCDs are driven to their maximum capacity. In older designs, I only had the like the teensy powering the LEDs, and it works, but it's not the best solution, especially considering that with the amp draw, the voltage drops below what the LEDs can take. So with this circuit, we now have a transistor array, an NPN and a PNP, and some other goofy business, so that we can use a 5-volt source with a 3-volt PWM and actually get a full range. So these LEDs are the brightest they can ever get. So you've got brighter backlight so you can see it better in the sun, and it won't overheat the chip. Yay! So ain't that cool? Moving on down the line, in the data department, now we are using proper data buffers. So those two little chips over there are data buffers. For the ECU, we have an inverting one, and for the TCU, we have a non-inverting one. So that gets rid of our standard, just regular NPN transistor in the previous design. So now both data lines have been isolated, so that way if you send bad things into the data lines, the buffer blows up instead of the main chip. This one was all about safety and doing things right, so now we got the pull-ups, and we even have a diode on the input pull-ups, so in case 12 volts goes into there, we're not feeding a bunch of voltage into the pull-up lines, so the 5-volt line is safe. Yay! And those buffers are awesome at making signals much prettier. They have a switching voltage of around 2.3 volts, so it works really well even with our 2.5 liter goofball, since that thing has a logic low of like 1 volt, which is really dumb. So that didn't work very well for our previous design. I actually had to make some voltage dividers to get that working properly, because before it would never turn off. So anyway, if you guys have never seen the Facebook page over here, Nick and Time Films, this is where we have all the updates. I update this thing like weekly on current progress. So if you haven't seen this already, check it out. There's lots and lots and lots and lots and lots and lots to go through. So yeah, check it out. If you like staying up to date, this is the place to be, especially if you're trying to be a prototyper, because by the time I even get to announcing this stuff on YouTube, usually the beta slot's already filled. So yeah, the V5 beta slots have been filled. and we'll get to why this is really annoying a little bit later. But yeah. Okay, so before we really get into all this crazy stuff, I want to see what everyone is interested in. So I had a poll running on the Facebook page, and I'm curious what the people on the tube think as well. So I've been thinking about splitting my my product lineup into an REM Junior and an REM 2 Plus. The 2 Plus would have all the fancy features, and the Junior would only do scanning. You have your data, and that's it. No extra business, no nothing, no crazy screens or options or any of that. The only option it'll have is Bluetooth and USB updating. Both of those will be options. So let me know which one you'd be most interested in. Obviously the Juniors, the biggest benefit to them is cost. They will be a lot cheaper, as we have here. So in this is something that we have spelled out. So the Juniors are planned to be anywhere from like 80 to 100, where the Plus 2 is anywhere from 140 to 175. Standards being cheaper, clocks being more. And this is the main thing. So the Juniors are basically what the REM Plus V3 was, but faster. And you can add Bluetooth. But again, it's really simple. So if we get on the list, like the fancy one would have an RGB display, and the Junior would have a single color. So you pick if you want green or red or yellow or blue, I think, and that would be it. So you're stuck into that, but it's a cheaper price. The main IC, that would be a big cost saver. There's less program space and all that, and it's a little slower, but nothing you would ever notice. It's still much faster than the older designs, but it'd be enough for the basic programs, so no fancy stuff. Timekeeping is out, fan control is out, extra in-out pins are out, no signal tuning, no micro SD slot, no in-out port. USB updating is optional, but there will still be the port on there in case you want data out, so we can still stream. You just can't update. You'd have to buy a like a bootloader upgrade if you wanted to be able to update your unit. But again, I don't plan to really change the software much. This is the basic software, and that's it. It would only get updates if things are wrong, or I can squeeze a little more in there. Bluetooth is optional. Gyroscope, no, and the DMM jack, which I'll get to a little bit later, is no. So that's basically, you see what you get a single color display with Bluetooth, and everything else is basic. It's a basic scanner, and that's it. So if you would be interested in that, let me know. From the current polls on the Facebook page, I don't want to throw off any of the thinkings that you've been thinking, but here's the current poll on the Facebook page, and the 2 Plus is 2 to 1 for the Juniors. So it seems still people like the 2 Plus features over the Juniors, but the main reason why I've been thinking about the Junior setup is because it would have been a lot easier to design. This is insane. This is madness. This has taken 3/4 of a year to figure this design out. If I would have scrapped all this, or if I would have put this off and just made a simple, very simple design that only did scanning, I'd have units out by now. So yeah, time. It's all about the time, and this took a lot of time. Ugh. As an aside, someone brought up an interesting idea to make a unit that had an upgrade board, like upgradable options. So we have like a giant header, and you get a basic REM with just the scanning bits, and then what I do is release REM peripherals. So I have boards that you can buy, like an upgrade board, that you pop into the unit, and then it can upgrade what it does. So you could have fan control, or you could have in and out, or tuning, or whatever the heck you'd want it, and it would be upgradable. So I get the base scanner out and going, so everyone can get a scanner, and okay, cool. And then if you want the upgrades, then hey, you buy an upgrade board, and you upgrade your unit, you put a new board in there, and like a little board, one that would take up like maybe half the thing. So you push it in there, and now you've upgraded it, and they're swappable and things like that. And it would let me design them better and time efficiency and stuff like that. But that would have been a lot nicer to know before I went through all this work, because this is basically done. This has everything it needs. So it's kind of silly to undo all of this work just to make it into an upgrade board. But it's an idea. It's definitely an idea. Okay, so to show off those magical buffers and what they do, here is our 4.0. So the red is the ECU input with the pull-up resistor. This is the first unit I've actually adjusted the pull-up resistors since Phil Andrews figured it out at the very beginning. So I've actually gone with stronger pull-ups so we can get a faster rise time. But if we look, the blue is the output from the buffer. And look at how square that is, dude. That is a perfect friggin' signal. It looks gorgeous. So that buffer really cleans up and gives you some nice sharp edges. Now here's the 2.5 liter. If you notice, the red is not at 0. It's closer to 1 volt. And that buffer still handles it like a champ, which is awesome. And no voltage dividers needed either. But here's the real kicker. So for some reason with the 2.5 liter, when the shift light is on, power is going through the data line. So if you notice now the data line's pulled up to, you know, like 9 volts. The battery was a little low, but that's a little interesting. The main chip can only take like 3 volts, so we can't really put 12 volts into there. So that's what the buffer's nice, where it gives a nice barrier between the two. But if you notice, the low voltage actually rose a bit higher to closer to like 1.4, 1.5 volts. And the buffer still cleans it up and takes it like a champ, which is amazing. So yeah, I'm fairly happy with the buffers. The only downfall with those little guys is they're only rated for like 5 volts, like 6 max. You can go higher than that as long as you stay within the current limits. So you can't go over like 50 milliamps, which fair enough. I mean, look at how small they are. But the problem is, the higher the voltage, the much faster you get to a runaway. Because I think it has like some kind of voltage snubbing circuit, so, you know, after 5 volts, it sends the excess to ground. But the problem is, the higher you go, the more it's going to send, and that heat escalates quickly. 9.5 to 10 volts is about thermal runaway, and she will very, very quickly go from, oh, I'm okay, to, yep, I'm toast, and let the magic blue smoke out. So, not super happy with that. The ECU line is the only real area for that to be an issue. So we actually have an inline resistor to keep the current down, and it does work. You know, it works fine, keeps the heat down. But I'd like to switch to a different buffer, one that's actually capable of handling 18 volts safely without, you know, crap like that. So I'm going to test that out for maybe the next run. But yeah, the data is much safer now. So moving on, one of the biggest, very biggest issues I have ever had with all my designs is the gosh darn voltage regulator. Dude, this thing has been the bane of my existence. Oh my lord. Dude, taking 14 volts and turn it into 5. What a frickin' process this is. So in past setups, I've been using what's called a linear voltage regulator. So what that does is it takes any extra voltage and burns it off as heat. That's not bad when you're going from, say, you know, 10 volts to 5 volts. But then when that alternator turns on and you're going 14 to 5, she creates a lot of heat, buddy. A lot. And they're big, too. Don't get me wrong. I mean, you know, I've tried the bigger's better approach. They only use 100 milliamps. This is a 500 milliamp linear regulator. Look at it. Look how big it is. She's pretty beefy. Not even close to enough, bud. On the clock versions, these things overheat if the clock's on too bright. It's terrible. For automotive applications that require any amount of power draw, linear just is not the way to go. So we have finally stepped up to a switching voltage regulator. So the chip at the very bottom, that is our 5 volt switching regulator. It's got an inductor and all the capacitors and all that crap to make it work. So what this does is, instead of burning off all the extra heat, all it does is turn on and off really fast until the voltage is where we need it to be, and then the capacitors just smooth out the voltage. So this creates almost no heat and should be able to deliver up to 2 amps, supposedly. So yeah, the 3.3 volt is still linear. That should be good up to 1 amp, but it's only taking 5 volts down to 3 volts, so that's not much. And there's even a diode in there, so there's a bit of voltage drop, so it's even less. You're closer to like, yeah, say maybe 4.5 volts to 3 volts. That's not bad. It's maybe a volt it's got to burn off. So she should be good. And considering there's like almost nothing on the 3 volt line, we should be fine. I've made sure to switch everything power hungry to 5 volt. So yeah, Hopefully we don't have any more power issues with these darn things. Oh my god, what a pain in the butt. So, let's get on to the fancy stuff, yes. So if you notice this ginormico switch over here, we've got dip switches, son. Gone are the days of frickin' and farting around with soldered joints and all kinds of complicated things. Now we got a switch. Just come in here and flip your doodad to whatever you need. So you can see up at the top, you know, you have the difference. For the fourth one, you can switch between the signal out or the oxygen sensor reading, the oxygen sensor heater relay. And for the other three, we've got fan 1, 2, and 3, or we've got 12 volt, 5 volt, or ohm. And that can be used for things. So I tried to make this more useful. So we have fan control built in. This big chip down here is our new relay driver. It is twice as good, maybe even more, than the previous design for the TFC. They just used transistors with a maximum current of like 500 milliamps. But you couldn't really do that because if you shorted them out, they'd blow before these fuses over here actually took effect. So I had to downrate them to closer to like 290, I think, 290 milliamps max. So this one right here is a Darlington Design. And what that means is it takes less input current to drive the output, which is good. The less current this chip has to deliver, the better. And I actually had one or two people have issues with the REMs, that the transistors were taking just enough current to overheat those darn voltage regulators. I felt really bad because they couldn't even use fan control without overheating the damn thing. I was like, really? They'd need the 1.5 amp Macho Mucho Giganto voltage regulator to fix that. By the way, that looks like this. This friggin' Grand Mac Daddy. That's enough, you know, to burn off the heat. 1.5 amps when the thing barely takes 100 milliamps. It's ridiculous how oversized you need to make those things. But anyway, now, the cool thing with this relay driver is there's a lot of stuff built in. So the input resistors are built in. There's 7 instead of 4, so I've actually ganged them up into 2s. So instead of 500 milliamp max, now we have 1 amp max per channel. That's awesome. And it's also got the snubber diodes, like the flyback diodes, built in. So all that nasty relay noise that comes when you close the thing, it all gets shunted. No more problems there. So yeah, I'm fairly happy with those. They're a little confusing. They don't work exactly how I thought they would as far as transistors go. I was going to use that 7th channel as like a battery input, so we could hook like a 9 volt up to it or something, but it doesn't really flow the way I was expecting to. I need to do more testing on that, but whatever. But yeah, so we've got voltage, we got fan control, and stuff like that. Alright, before I branch onto the adapter and the second part of the in-out, I just wanted to continue the in-out. So notice this little jack over here, this guy? This is going to be our bonus nachos in-out adapter. So this has a few more ports. We've got, on the main input, we have safety. So no matter what you put into there, it should be good. For this one, it's more, what's the word I'm looking for? Safe, squishy, not durable, sensitive. So the inputs on this are a bit more sensitive. So we've got a 5 volt in, and we've got a resistance reading. But the resistance reading does not have a diode protector. So don't put 12 volts into there, please. That won't be very good. But this jack is for like inside. For me, I'm going to be using it to read in my my wideband oxygen sensor gauge for tuning. But it's got 3 free pins that I haven't decided what to do with them yet. I think one of them will be a 5 volt line in case you got to pull anything up or provide voltage to anything, and then the other 2, I don't know. Again, I don't really have too much more board space to fit anything else. That's what the extra jack is for. So this is our little micro wire that fits into here. And the cool thing is, it just clips into place. Like so. Which is really neat. So you get 6 wires over here. It's a little short, but you know, you can tap them into whatever. This we actually have hooked up to a fuel pressure sender. So I will show you that in a bit. That is really cool. I ordered this off eBay, so we can finally hook into the fuel pressure rail and see what the heck our pressure is. So that is very neat. And it does come out fairly easily. There you go. Boop. I finally found a fuel pressure sensor. So this has an adapter over there that fits right into the fuel rail. It is a -4 Army-Navy fitting that goes to a 1/8 inch NPT so that it can accept a sensor. So this guy I got off eBay. It's just 100 PSI, you know, pressure sensor. So it's good for like fuel and oil and all kinds of stuff like that. And yeah, it just screwed into place. Looks pretty good. I put the connector on and it seems to work. They even give a readout so I can figure it out without having to try to figure it out. 0.5 volts is 0 and 4.5 volts is 100, and it's linear. It does all the work for you. So all you gotta do is read in the voltage, do some really simple math, and boom, you got PSI. So that is kind of cool. So I may or may not include that as an upgrade if anyone wanted a fuel pressure sensor. The only issue is the Schrader valve needs to be removed from the fuel rail for this to work. I couldn't find an adapter that pushes the Schrader down and leaves it in place, because that would be nice. That way you could pull the thing off and everything would be happy-dappy. But yeah, I don't know. Still, ideas. It's all about the ideas. See what sticks. That's the bonus nachos in-out port. So yeah, that's most of the features gone over in there. This is a super professional, safety inclusive design. So let us go over our adapters. So for the this beta run that I'm running, I've got 25 boards, and I'm really regretting that decision for how many I got. But here are the new adapters. So now we've got 4 ports instead of 3, and they're labeled. So slides out from the front. This is our regular adapter. So we've still got our 4-liter, 2.5-liter switch, and we've got our 4 finger dingers, and we've got an O2 jumper. So in case you wanted signal instead of O2 for the 4th port, you can do that. You just have to unsolder. Yeah, I know. Still couldn't get completely away from the jumper unless you go up to the bonus nachos version. So this right here is the digital multimeter port. This was a new feature that I thought about sort of kind of last minute, but I wanted to try it out. So we have a banana jack in here for multimeter probes. These guys over here, yeah, with the probe and the pokey bit, and you stick it in the receptacle to see the angry pixies, yeah. You can get one of them for your REMs now. So you just take this doodad and fucking slip it on in there, and hey look, now you can read stuff. Ain't that cool? So, if we flip it over, we can actually see what it is. We've got voltage, resistance, and signal for testing. And that's what that big gray switch is for. So you can change between the 3 different modes. And on the REM, we'll have a readout screen for like the voltage and the resistance. And if it detects the signal in any sensor wires. So the signal, basically, it would just read 5 to 0 constantly, like in a pattern. And if you put it in like a sensor wire, the REM would try to see which ECU input it is and say, okay, yeah, this one's good or whatever. But that's another thing. Over here, the signal out generator, or a little op amp. That little guy, the little boy right there. That is a now rail-to-rail op amp, so it can do actual 0 volt to 5 volt instead of like the 0.9 to 5 that we had before. So that's cool. And it's got the same pinout, so if you were really, really good at electronics, you could upfit your V4.1 to have a proper rail-to-rail op amp. So yeah, signals are cool. Signals are cool for tuning. But yeah, that's that idea. So you can see it kind of reaches decently far. I'm still deciding if that's going to be a feature that sticks around and how useful it'll be. But I guess it gives some use to the in-out stuff. You know, something to think about. Okay, so here's the idea for the DMM upgrade. Again, this is just something I had an idea for, and I wanted to try it out. So, you don't even have to take the cover all the way off, but if you do, you get to see what it all does. So, our big gray selector switch will change between voltage, resistance, or signal out. And we've also got the regular switch for 2.5 liters or 4.0 liters. So that's what these are. So, this guy's our voltage, resistance, signal. And the black one in there is going to be for the engine, but that's going to be a lot harder to switch with that gray switch in the way, so whatever. But take that and put that in there, and then you got one of these guys you can go probe around. So you can check the battery, or, you know, sensors, or how far does this reach? So you can almost make it to the other side of the fender, maybe if it was rotated a bit. So you can almost go all the way across the engine bay. So you can test most things, most sensors and stuff like that to see what it's all doing. How useful this will be, I don't really know. The biggest downfall is that this is ground referenced. So, you know, when you're using a normal multimeter, you have a red and a black. Well, the black one is already built into the adapter. So the black one is permanently connected to ground. So if you're trying to measure something that is not being ground referenced to the vehicle, say for instance, you pull a sensor and you want to see the resistance. Well, you can't. You can check the one end over here, but the other side has to be connected to ground somehow. That is the only downfall, and I'm not really sure how to fix that. I mean, what you could do is, you know, add another port in here to go to ground. But yeah, that's where things get complicated, because normal multimeters, the ground isn't all connected and all that, and you'd have to make a separate reference ground so you don't short anything out if you put the ground probe on the wrong pin. And I don't know. Again, this was an idea I wanted to try, but I knew it was going to have some downfalls. Whether I keep it or not as an option, I don't know. But I thought it was interesting and maybe put a little more usefulness into the in-out system. So, because now we got voltage and resistance and signal testing, so that's what that does. So as far as all that goes, yeah, that is everything that I've been working on. It still has optional upgrades too. We've got Bluetooth, so we can still add Bluetooth. We can still add gyroscopes. The gyroscopes are really hard to find. There's like none of them around. I don't know what the deal is. This version, Adafruit, has not been very good at keeping these in stock. They are hard to get. And looking at the core components that it uses two main chips. The one chip seems to be in stock everywhere. You can find them, you know, by the thousands. But the second one is out of stock in most locations until, DigiKey said until late October, and Mouser said like early January or February. So yeah, I don't think we're going to have gyroscopes anytime soon. You know, you can still add them on later, but I can't get them right now. You can't even physically buy the chips for them, so couldn't even make one if I wanted to. Unless I want a different version, but that's more coding and... But anyway, there you go. That's the REM 2 Plus in a not so tiny nutshell. The next version I plan on making is the clocks, but again, it's going to take a lot of design time, man. This stuff takes time. You know, like I said, it's taken me, you know, 3/4 of a year to get this crap figured out. I mean, can you make heads or tails of that schematic? Got the main chip, the USB, the buttons, the bootloader, the analog reading, the LCD drivers. We got our data inputs, SD cards, voltage regulators, the jack, all of our in-out bull stuff over here with the switches and the things and the stuff and the do. Oh my lord. Just testing all this was a friggin' nightmare. So yeah, the clocks are going to take a while, especially considering I want to get injection molded cases. The guy that I've been kind of talking to for the past 2 years on and off, bless his heart, man, I feel bad. I've been putting them off for so long because I just don't have the time to, you know, give him the things needed. He got a model together for me, and, you know, once I get the clock board laid out, I really want to see if he can get me some cases designed. I would absolutely love that to death, but I just haven't had the time, man. It's all about time, and I've had none of it. Stuff takes too long. Too long. Alright, so, yeah, as you can see, lots of time and effort put into these things. I'm really hoping that they're getting real close to being ready to sort of kind of mass produce. Again, I still have the notion of I'm going to put the final bits together, but all these little things are going to be put on by the PCB manufacturer. So hopefully that makes assembly time a lot faster. That's been the major goal, is being able to build these faster, because I can't do this by hand anymore, and especially with the previous designs, it wasn't feasible. So this was necessary to make them quicker. hopefully. But again, I've been trying to build these by hand. I've only gotten 5 done. Dude, it takes an hour just to put all the little components on each board. And I run them through my new fancy toaster oven, and they don't really turn out the way I was hoping. So yeah, I'm going to make an entire video on that, but I built a reflow oven. You know, anyone that's been in stuff like that, meet the Franken reflow. So we've actually have a tiny reflow controller in here, and a Walmart toaster oven that has been retrofitted to be a reflow oven. So you put the board in there with the paste and all the little bits, and it cooks it at the proper profile so the solder melts and it does all the stuff and things, and it's supposed to come out beautiful and perfect and wonderful and all that crap. Yeah, that ain't quite it. So part of it is definitely my fault for not knowing how to friggin' put down paste. But we get lots of solder bridges like that. And on a board like this, it's like, oh, well, that's nothing. Well, yeah, but how do you think it is when you get crap like this? And all those itty-bitty little pins are jumped together, and capacitors are flopped around and not where they need to be, and resistors are all over the place and tombstoned, and the voltage regulators are never on right, and all this crap. And you gotta sit there and rework it, and it's like, really? Did I actually save any time? I might as well just do the frickin' things by hand. So, I've got this this guy over here, this rework station. It's basically just a glorified, you know, hot air gun. Shoots all the hot bits out and does the things with hot air. So I'm going to try making the boards with this again, like I did the TFC version 1, and see if that makes it easier. Because again, like I said, it takes an hour to put all this in here, 2 minutes to run through the toaster, and then probably another hour just to rework it to get the damn thing to work without bridges and everything where it needs to be. So I might as well just take the frickin' 7 minutes it takes to use this to just reflow them and, you know, skip an entire step. So, you know, I didn't dump a lot of money into that thing, but it's upsetting that it doesn't work the way I thought it would. But again, it might have to do with how much solder paste I put down. I'm not very good at using the stencils, and I get way more paste than I need to. So if I could keep it thin, maybe. But I still don't understand why components like explode and jump around like popcorn and fly all over the place. I still haven't figured that one out, but whatever. As a bit of an intermission, if you've ever wondered how many parts it takes to make one of these things, well, here you go. Here's a big old box of parts. Parts, and parts, and parts, and parts, and parts, and parts. Oh, parts? Yeah, still parts? Oh yeah, parts. Dude, it takes so many little bits and pieces of frickin' sand. Here's the TFC, I think. That one's a little less parts, but still. Yeah, we've got a lot of them. And I've actually tried to clean things up a little bit. So say hello to this, huh? Huh? Oh my god. Professionale, huh? We're actually using some frickin' shelving space for once. So I've been trying to organize my components by where they come from or where they go, or if they were assembled by Cotton Eye Joe. So yeah, I might actually be able to find the stuff that I own. Wouldn't that be nice? So yeah, toaster, parts, things are clean. Yeah, I guess that's it for an intermission. Back to boards. So now after that little intermission, I'd like to move on to some things I'm a little more excited about, honestly, because the REMs, with all the problems and complications, they're starting to leave a little bit of a bad taste in my mouth. I might have bit off more than I could chew there. So it's fun to go back to tiny, simple projects that work. So here is the Trinity version 2 fan controller. So these things are really cool. So I've got a few of these built. They're going to go out shortly, but I just wanted to show some things off. So I guess first we'll start with the case. So the case has been slightly upgraded. For the version 1 prototypes, I've heard a few people saying that the cases were a little thin and too flexible. So alright, fair enough. So I've beefed up the cases so that they are stronger. And I finally think I figured out a solution for the switches over here. So when we slide this guy open, in the previous design, I had like an entire right angle piece that was part of the door that would slide on there to cover this hole, but it made things a lot weaker. So what I've did instead is I've made a little adapter piece that fits into there, and that will fill the hole, and it's got a little slide bit in there, so the door will hold it in place. So now we're much more rigid and as clean as I can get for a 3D printer. The thing that you got to remember with 3D printers is the tolerances are hard to keep tight. So making small pieces like that is damn near impossible. I had to actually, completely change the way that the printer prints these out just to keep them from warping everywhere. Because the problem is when they're so small, they're too hot and the plastic doesn't cool and they just warp and they're all kinds of crap. So I had to build like a raft wall that it changes between so that it cools down fast and it stays clear and all that crap. It's a real pain in the butt. But yeah, that's going to be a much better design. And I've got a little exclamation mark there so you know when the override switch is on and when it's off. So in case the unit ever bugs out, you can manually turn fan 1 on and off. So there's that. And if you notice this, we've got a rear-facing port. So one of the users was asking how tight of an area we could fit it in, and I figured, hey, I've got rear-facing ports. Let's see if that works. So there you go. We got a rear-facing port, son. Chiggy-doot. Pretty cool. So getting the thing back in, just pretty nice. So, yeah, before we get into the little bits, I guess I'll show off the adapters. So the adapters definitely needed the most work out of anything. So we've got a few different designs here. The little push-down ones that we had, where you pushed to open the thing and put the wire in, they sucked butt. They didn't hold on very well. They were really hard to use, and they weren't good. So now we switched to screw-based designs. So you have to screw down to tighten the wires. They hold a lot better, and they're just, it's better. So yeah. Now we've got a 45 degree, so it's a lot easier to get to, and even a 90 degree. And even a 90 degree, which I don't know how many people are going to use, but I know for the way mine is set up, this will be useful for me at least. That's the cool thing about making products for yourself. You can make them the way you want. So yeah, we got a little 90 degree for the wires to slide in. Still the same layout. So we've got all our pins in there. Now, number one important thing, I've switched jacks. So in the previous design, we had regular jacks that use like these through holes. So all these pins are sticking out of the bottom. Well, the problem is the way that these adapters have to slide in, there's holes down there for everything to fit underneath. And water gets in there and it corrodes out. And I actually had one case where some guy said he was washing his Jeep and his fans started coming on by themselves and he couldn't figure out what the heck was going on. The fan controller was freaking out, all kinds of bad things. And I'm like, well, that's weird. Let me try that. So I filled the adapter full of water, was spraying down my Jeep, everything was fine. I'm like, I don't really see an issue. I don't know what's up. And then about 10 minutes later, when it started to dry a little bit, mine did the same thing. Corrosion issue. So what I've done is switch to a surface mount jack. So all the pins are on the top and the top only. So now you can tell when things are going bad because they'll be on the top instead of on the bottom, hidden from you. But we couldn't just stop there. So now we have a special silicon conformal coating on the board. You see that reflection on there. We've actually got a protective coating to protect the board. So we got this stuff right here. And this is meant to protect circuit boards and circuits and things like that. It's a clear liquid you can brush on. And it covers the board and keeps it sealed, keeps it, free of moisture and dirt, contaminants, all that bad stuff you might find in there. So that should keep our pins a lot cleaner, and even if, water gets on it should just run right off, not be a problem. As a secondary thing, now the only thing we have are like the main adapter pins underneath for the, the green jack and all that. So I've actually made drain holes. So if water ever gets in, water should be able to get back out. It almost looks like a harmonica or something, but hopefully that helps in the long run if water gets in there. I'm having a hard time trying to figure out how to design these adapters well. I've spaced these out a little farther so you can get sockets in a little better. I heard with the V1, the version 1, these were a little too close together, so you couldn't really get a socket in there, or you had to put it in at a funky angle, so hopefully that helps a bit. But yeah, just all around better upgrades, so hopefully these are better, but I don't really know how to make the case any better to be still usable, and you can't really make something sealed that it doesn't work that well, so I don't know, let me know if you got any ideas for how to make this better, but that's about as good as I can make it. I don't know. Again, with the conformal coating and all the other upgrades I've had, these things should be able to last just fine. But we got one more. So, some guys weren't happy about the bare wire stuff, so for those, we've now got spade connectors. So this way, you can put them in either these guys, so this normal spade dealio, so they will pop on there, or you can even use the fully insulated jacket versions, like those guys, for full-on condom protection. Safety first. So spades are more your style. Well, there you go. That is an upgraded option. And the reason why this is possible is because of that surface mount jack. So the cool thing is these adapter boards are dual-sided. So if you notice, this is side 1 with the spade stuff and everything. And this is side 2 with the non-spade stuff. So the only issue is like some of them stick out over there, but whatever. Different lengths and things, what do you want? But I thought that was really cool that because the adapter only has the pins on one side, I can do like a dual side, and I thought that was really cool. Fancy that all the pins actually fit in there, and I could get all the wiring done, and that was rather creative. But I like when things are small. If you notice, when I make things, they are tiny. I make them as tiny as possible. I love efficient building. I don't like unused space and a bunch of just no. We make the most of everything here. So, here is good old version 2. So this shares a couple of the things that the new REM does, and it was because of the Trinity that I was able to figure this stuff out. But we have a proper, relay driver as well. So we're not using like transistors anymore. This is a proper relay driver. It's actually the same exact version in the REM, but it's a different package. So it's still grouped up the same, so these should be able to handle, theoretically, up to 1 amp per channel, which is really cool. We've also got a bunch of other little things going on here. Don't mind the wires. Again, this is a prototype, so I'm testing things. I found out that we need a diode, like a safety diode for the our flyback on that, because if for some reason your ignition goes to ground at any time, your fans will all turn on because they flow through the flyback diodes, and that's not good. So now we have a diode in the reverse direction, so it has to go over 20 volts before all that noise can go find its path to the happy place. So yeah, that's just a little fix. And it's a little cleaner on the boards I'm actually selling to people. So if you notice, there's no wire jump there. It's just a itty bitty little buddy right in there. So that right there is a 20 volt Zener diode. Or actually, that one might be 18 volts. But yeah, that just keeps the noise down. And actually, I can show you guys what they do. So if we come into here, we've got screenshots. Very nice, yes. Okay. Hey, baby girl, how you doing? Why are you over there? Okay. So this right here is what our new Zener diode does. So this is specifically designed for a very quick breakdown voltage. But if you notice, it's an 18 volt, and the noise still gets up to like 32, 33. So yeah, it's very strange how that works, but I guess with how quick it is, that's just how it works. So if you notice, once we hit that breakdown, when it finally does break down and allow that reverse voltage, it stays completely steady, and then it starts to kind of waver, and there's a bit of a jaggedness to it, which is interesting. Now we compare that to this right here. So this was with a 20 volt Schottky diode instead of a Zener. Now the Schottkys have a lower voltage drop, But besides that, yeah, this was a 20 volt, and if you notice, the breakdown voltage is way higher. We're up at like 45 volts before that darn thing finally lets the voltage through. It's a bit high as far as the noise goes. But if you notice, when it does drop off, it drops off very smooth. So I don't know. Interesting. But yeah, the Zener, definitely a safer approach. So now we've got the flyback protection, so you don't accidentally turn your fans on when your ignition goes to ground, like mine does for some dumb reason. So yeah, we got that. There's also more bonus nachos features in here. So, let's see, what do we got? I've tried to make the pins a little more useful. For the second temperature input, I kind of goofed. It's a pull-down resistor when it should have been a pull-up. So that feature doesn't work, sadly, but I don't think anyone is really going to use a second temp sender besides me, because I like to look at the thermostat and the radiator and flip between the two. But for the main voltage, you notice we have a dip switch in here. If she'd focus, thank you. Very tiny. But we actually have a multifunction input. So now we have voltage or resistance. So the resistance-based sensor is the way that it normally works. When you plug a probe in, it reads the resistance and you're good to go. But if you wanted to try to like tap into a factory sensor, you need the voltage reading because the factory sensor already has all this pull-up and all that you know, driver circuitry. So we just need to pull the voltage. But that requires a bit more math. So we need to figure out what the input voltage is and the input resistance so that we can calculate the output resistance. So with some fancy probing, we can actually figure that out. I actually had a buddy try on his 98 Cherokee to see what his temperature thing was, and we found out it was a 5 volt input with like a 3.3K resistor. And with those two variables, we can calculate what the output is based on the voltage. Complicated, yes. And it gets more complicated. So say, for instance, we don't have a like a steady input voltage. For instance, the oil pressure sender on my Jeep for the gauge, the input voltage is the battery voltage. So it's changing. So now we have a variable, which is really annoying. So in case that ever comes up, we actually have a voltage reading circuit over here. So now we can see what the battery voltage is, because we had free pins. So yeah, one of the shortcuts now, when I finally program it in, you can see what the input voltage is. And yeah, that'll be pretty cool. So you can see battery voltage or temperature. So we've got our dual input, we've got battery voltage, the second temp probe doesn't work, but now we have a more useful switch that someone was asking about. So we have a extended runtime power switch. So the way that this works, on here, this the E1 input over here, that was going to be a multifunction, but I kind of goofed that, so you have to ask me if you want temp. But this is going to be for our extended runtime. So you put ignition into the 12 volt because that's what turns the unit on and off. But if you put 12 volt hot into the E1 pin, this switch over here down at the bottom can actually keep the TFC on when the engine turns off. So it'll have a couple different modes. You can either have a set timer or a set temperature, or maybe just whatever one comes up first. But yeah, basically you run 12 volt hot into there, and when you turn the key off, the TFC can stay on and run for longer, you know, for a set time. So you want it to run 2 minutes after the engine sets off, or you want to run until it hits 150 or something like that. You can do that. So that is a cool feature with that new power switch. So I'm excited to try that out and code that and see how that works. So now our extra pin is extra useful. Cool. On top of that, we actually have, I'm really, really proud of this, a smart AC input. Dude, this thing is really cool, and I'm really excited that I was able to make this work, because it took a lot more wiring finesse than I thought it would. So let us show you what it looks like. So for anyone that can appreciate a nice circuit schematic, I've actually been working on making more professional schematics for my designs, so it's just easier for me to read. But would you take a look at this Smarty Pants design? So this is interesting. So just to show off. So the our relay driver over here, we're just using a transistor as our switch input. So anything over, I think for this, it's like 1.3 volts, and it turns on. Anything less, and it turns off. So this can accept a 12 volt signal in, or a ground signal in. So let's run it in the way that normal people would use with the 12 volt. So when 12 volt comes into here, the diode gets ignored, and we have a voltage divider. So this brings our 12 volt down to something much smaller. I think it's a 5-to-1. So what that means is I think it has to be at least 8 volts, 8 or 9 volts for the switch to turn on, and that's good for noise rejection. So that way, if you got like a slightly noisy line that's bouncing at like 1 to 2 volts for some weird reason, or you got like weird pulses, this should take care of a lot of that, so it's a lot smoother. So we got our voltage divider. And if you notice, we have a transistor over here that is allowing the voltage divider to ground. So we have to power this line for this voltage divider to work. Now, the important reason behind this transistor is when we come over to here. So, say we wanted to use a ground signal. So when the line is grounded, we have AC. When it's not grounded, we don't. That's what this guy is. It's a pull-up. So it's a 5 volt going through a protection diode, so you don't backflow into 5 volt for some dumb reason. But the 5 volt line pulls this high, and when you put ground, it pulls it low. But the problem here is that the 5 volt can't make it through the voltage divider because it gets dropped way below the turn-on voltage of the transistor. So this never actually pulls this side of the line high, except when we turn this off. So when we turn the transistor off, this is no longer grounded. The voltage divider disappears. So then all it is an input with a slight resistance. That's it. So now 5 volt can get into here without the divider, pull the line high, and when it goes to ground, this turns off. Dude, that is so friggin' cool. So this is always on. There's the 5 volt is always coming in. But when we turn this on, it cuts it down so the transistor doesn't turn on by accident. Dude, that is so friggin' cool. We have a digitally controlled input for 12 volt or ground. I am so friggin' proud of this. It took a couple nights to figure that one out, but oh my god. I had to share that because I thought that was really, really cool. So with a little flip of a digital switch, we can turn that on to, whatever we need. So yeah, again, I am aiming for this to be the world's smartest fan controller with all the features you may ever need. Yes. Alright, so I think that just about shows everything off for the Trinities. So when I finally get mine installed on the vehicle and running and all that, I want to make a proper demo when everything's coded in, so you can see just everything this does. But seriously, if you need to control up to 3 different fan channels and have very customizable temperature control to keep your temperature right where you want it with any kind of input or just anything you need with a fan controller, this should be able to do it. So yeah. I actually still have a lot of those left, so if you'd like to be a tester for the version 2, let me know and I can get you set up with one of these guys. Lots of options. And a few more, if I may. So I've actually got 2 different options for temperature probes. So the included probes, we can now get a threaded temperature probe now. So if you have something that'll fit in a metric 8 thread, or if you can find yourself an adapter, you can thread this into some kind of water coolant jacket or whatever for people that wanted direct water sensing. Or we still have the normal push-in probes. So this is going to be the default that you get unless you want a threaded version. This will push right into your radiator and be good to go. Now, the only downfall is a few people have noticed that these get air-cooled, so when they're on the highway, it reads way lower than it should. Mine doesn't do that, and a few others don't. So I'm not sure why some do and some don't. But one guy fixed his by putting like a little tiny shield in front of the sensor so it doesn't get affected by airflow. So it only reads the temperature of the radiator. But yeah, that's the 2 temperature probes options. So yeah, that should be everything I think that I covered with the TFC. I've used every single line except for one. So there's still one freebie in here, little A2 over there. Everything else has been put to use for something or another. I even had a battery input idea. Again, I still haven't tested that to see if that works. But yeah, these things are nuts. I'm really excited. These are fun. You know, this is simple and fun and just super cool, and it's giving me that hope again. You know, it's fun, and that's why I do this, because it's fun. So yeah, because these REMs are driving me a little nuts. I'm kind of losing. I'm losing my losing a bit of my stride with these guys, because they've been a bit difficult to work on. I've been kind of killing my spirit with just how overly difficult and obnoxious and yeah. So yeah. But anyway, I've been trying to work as hard as I can to get the REMs out. The TFCs, I'm really happy about. These things should be friggin' stellar. I fixed all the issues with those. So yeah, I guess the only other thing I could show off is a little mini project I've been working on. So yeah, for everyone asking, so when the HO guy is going to get some love? Well, we got a little bit of love. Not a lot, but a little bit. Give me a second to bring the love up. Okay, check it out. I present to you proof of concept for the TCU Buddy. So what this is a transmission readout, and that's it. All this does is show you anything the transmission computer can read for the AW4 automatic transmission in the Jeep. The interesting thing that I found out is that the Renix and the HO TCU output the same data. Exactly the same. Dude, you could hook an REM up to the transmission computer and read that on an HO. You'd need the proper adapter, but you could get transmission stuff. But don't get too excited. The engine stuff is still way different and way more complicated. So that's a ways off. But if anyone was looking for a bit of a stopgap, this could be something kind of interesting. So we've got speed. We've got the gear. We've got the what solenoids are on, what your TPS is showing, but this is only going to be 0.7 because it's only in steps. The transmission RPM, if you're in power or comfort, if your shifter is in first, third, or power reverse neutral drive. They don't really tell you any of the in-between ones, which is kind of dumb. And if your brake is on. So that is a live readout. And we've got a few things. The buttons aren't hooked up for some reason. Well, you know. But anyway, there's a menu. It's a real basic menu. All it does is it lets you change the tire size, the gear ratio, mile per hour, kilometer per hour, and I think I'm going to make one of these buttons a for low conversion, because this is only reading from the transmission. So when you shift the transfer case into for low, it doesn't know what the transfer case is doing, and that throws off your speed. So when you're doing like, you know, say 15 miles per hour in a trailer, it's reading like 35 mile per hour. So that's not going to read properly. But anyway, this is just a proof of concept. I haven't even designed a board yet. And I don't even know what to do about adapters for the HO guys because they're so different. I don't know. Making adapters is going to be really difficult. So if you want to splice into your transmission data line, then hey, you can make this work. So far, I'm only making this because one guy was interested, and he actually paid for a screen. So we are going to boost this up to the good old 2.7 liter. Or the 2.7 inch OLED screen, so this one is a lot bigger. But it's going to be the exact same thing. If you saw the REM that I made with this screen, the OLED version, same exact screen. So yeah, that's an idea. I'm going to poke around with that, and I guess I'll show that off if I ever finish it. But just figured, in case you wanted to see some other stuff, HO guys, you can get a little bit of love. Again, let me know, I guess, if you'd be interested in that at all. But it's really just a little transmission readout. Okay, so yeah, besides that, I just got to work on the REM clocks. And have a company make these boards, because these are hell in a handbasket to try to put together. But yeah, I guess that's all for now. That's enough rambling, so... Yeah, if you want to stay tuned, check out that Facebook page. That's where everything gets posted, forevers. Instagram, I occasionally post stuff, and YouTube's been a little slow with the development cycle taking so long. But yeah, let me know what you think about everything. I think that is all for now. So until next time, hopefully in a couple months I can actually have products in stock and no more prototypes and no more of this goofy. You can just go on the website and order stuff. Which, hey, by the way, did you know I have a website? Nick in Time Designs, son. Tell me that doesn't come off the tongue. Ooh, baby. Not much on there, but you got download, support, product information, all that. So, yeah. Stuff and things. Alright, that's all for now. Thanks for watching and supporting and all that. You know, it's only because of you guys that I'm able to do all this fun stuff. Because this is a lot of fun to an extent. Turning fun into a business is not as fun, but it's always nice to see those smiles when people get their products for the first time and go, oh, dude, this is the coolest thing ever, right? If I'm on the Facebook page and I happen to glance at someone's dashboard and they got an REM, it's like, oh, that just brings a big old smile to my face. So it's because of you guys, man. I do it because this is a passion project. I do it for fun. So, yeah, if you can have fun doing what you love and make money off of it, you won't work a day in your life. Alrighty, that's all for now. Goodbye.